So, as we introduce ourselves to circles, which is Unit 4, we need to understand that the vocabulary in this unit is very, very important as we start digging into some of the theorems we'll use later on. So, this first slide deals with the vocabulary of a circle. And remember, we label a circle by its center point, which here is point A. Then we have the radius of the circle, which we've talked about before. The radius is made up of the endpoints being the middle point and a point lying on your circle itself. And then the diameter is twice the radius, or in fact, a line that goes through the center of your circle that kind of cuts your circle in half. Then we have a secant line, and notice the secant line has arrows on both sides. In other words, it's a line that intersects your circle at two different points. Then we have a chord, and notice the chord does not have arrows on either side because it is a segment whose endpoints are points that lie on the circle itself. And finally, we have a tangent line to our circle. A tangent line is a line that intersects your circle at exactly one point right here, which is called the point of tangency. And what's special about a circle and what you're going to be using for the next few examples in this lesson is that a tangent line is perpendicular to the radius, and where they intersect is that point of tangency, or where they form their right angle. So we need that information down here on example 2. Notice we have find the missing segment. Assume all lines that appear tangent are tangent. So here's the only line that appears to be tangent, and we know it's tangent because right here where it intersects the radius is a right angle. So we have a tangent line right here. Then we have two radii which make up the diameter. We were given that this piece of the diameter, or this radius, is 3. But the radius is the same no matter where it's drawn on your circle, which means that even though we weren't given this 3 right here, we know it's 3 because we know this line is a radius. And we're trying to figure out what x is right here. So because this line is tangent, it intersects our radius at a right angle, which means we have a right triangle here. And we can use the Pythagorean theorem to figure out what this missing side of our right triangle is. So we have a squared plus b squared equals c squared, where c is the biggest side of your right triangle, or your hypotenuse, opposite your right angle. So c has to be our x here, or what we're looking for. Then we have 6 squared making up our a squared, which is our diameter of the circle. Also, it is one of the legs of our right triangle. Plus 4.5 squared, which is the other leg of our right triangle. So 6 squared is 36. 4.5 squared is 20.25. And then x squared we don't know yet, so we're just going to bring that down. When we combine these like terms, we get 56.25 equals x squared. And then remember, to get rid of the squared on this x and get x by itself, we take the square root of both sides. When we use our calculator to find that, we figure out that x equals 7.5. And notice 7.5 is the bigger number out of this side, 6 and 4.5. Which means that we did this right because our hypotenuse has to be the biggest side. Then we move on to example 3. This is the converse of the theorem we used in example 2. It says, determine if AB is a radius, is a tangent line to the circle. So in order to figure out if AB is a tangent line, we need to figure out if where it intersects our radius, point A, or our point of tangency, if those two line segments end up being perpendicular. In other words, is this a right angle? We can do that by figuring out, is this figure created here by all of these different lines a right triangle? If it is a right triangle, that means this angle has to be a right angle. So we do a squared plus b squared equals c squared and see if they end up being equal or not. Well, our C is going to be the line opposite the angle that we need to be a right angle, which is this side right here, made up of a radius of 12 and then this little segment of 8. So we add those together and our C is 20. So we have 12 squared plus 16 squared equals 20 squared. And when we work this out, we find on the left side of our equation we have 400. And then on the right side of our equation we have 400. So because a squared plus b squared equals c squared, this is in fact a right triangle, meaning that this angle is a right angle, which also means that AB has to be a tangent line to our circle. Then finally, our extra example is kind of like example 2. Find the missing segment, assuming that all lines that appear to be tangent are tangent. Well, the line that appears to be tangent is x right here. So we are going to assume that it is tangent, meaning that it has to be perpendicular to our radius right here. So when we work this out, we have a squared plus b squared equals c squared. And that's how we're going to figure out what the length of this tangent segment is. So here's our a squared, or I'm sorry, our b squared. Here's our a squared. So we have x squared plus 4.5 squared equals 7.5 squared, which is our c, our biggest side length of our triangle. When we work that all out, we figure out that x equals 6.